question like this. It's saying we are given the top view and the front view of a non-transparent cylinder. Okay, it's drawn in the first angle to the orthographic projection. The instructions are simple. They're saying you have to draw 1.5 10 in right-handed, meaning anti-clockwise, helix starting from point P. Okay, so our point P is here. So we have something like this. You have like to answer the following questions after drawing your drawing. Okay, so we have to answer what is the size of the pitch, what is the developed length of the helical curve in 1 revolution, meaning in 110, what is the size of the helical angle. Then we have to show all necessary construction and hidden detail. So here's our question. We have our 30 radius from the top view. This is first angle. So this is the front view here. We have 100 millimeters of the height. Then this is our starting point of the helix curve, meaning it's going to have to go this direction because it's right hand. Remember I said right hand, you use your right hand. So we are going this way. Okay. So I have already completed the drawing. I don't want to waste more time doing more drawings, and I've already explained in the first drawing what is happening, how you do it. So I'll just simply explain this drawing in simple words. Okay. So remember the question is like that. This is the final answer, meaning we're given the top view and the front view. The first thing that you want to do, remember that I said it's 1.5 10, and it means we're going to have how many halves? Three halves. Yeah, so we're going to have 3 halves, meaning this is our first half, second half, third half. So it means we have to divide this 100 from here to here by 3. Okay, so this is what I did. You divide this 100 here, you get this answer, 33.33 millimeters, meaning 110 is equal to 33.33 millimeters. So it's going to be 3 times, meaning from here to here is going to be 33.3, from here to there 33.3, from here to there the same thing. Okay, so 1 full 10 is equal to 66.66 millimeters. Why is that? Is because 1.5 10 is 33.33, meaning you times that by 2, you're going to get 66.66, which is from here to there. So now you will be left with 33.3 from here to there. So the next thing that you want to do is you want to divide this 66.66 into 12 equal parts, since your top view is divided into 12 equal parts, right? So you start doing this. You know this method already. You use this method. This angle here doesn't matter. Remember that you divide it from you divide it with like 12 equal parts, so 1 2 3 up until 12, right? Then it's going to take you here. Pretend that you don't see these lines for now. So what you do is you project all these lines to this height, to this line here. Then you use construction lines to project them, to draw them across your cylinder. Okay, you do that. You already know the method. And then for this half 10 here, remember they said 1.5 10, so it means now we are only left with 33.3, which is from here to there. You do the same, but now it's the half. So half of 12, remember this is a full 10. If a full 10 is 12, it means the half is going to be 6, meaning we're going to have 6 tens now. It means we're going to have 6 equal lines for a half of a 10. If 110 is equal to 12 parts, so now we're going to have 6 parts. So you do the same method, you divide it like this. I decided to use 5 millimeters for these parts here, so that I don't use more space, because if I use 10, it's going to be long and out of my paper and gonna cause me problems now. So you basically do that. You divide this line here with 6 equal parts, then you do the same method, you know the method. Then after doing that, you project the lines across your cylinder. Okay, then you divide your circle, meaning your top view, into 12 equal parts. So I've decided to put my one here. We are going anti-clockwise. So if we were going clockwise, we're going to go this way. Now it's anti-clockwise, meaning we're going the opposite direction of the clock. Okay, so we're going anti-clockwise, meaning we're going this way. So our starting point is P. So I've decided to put my one here so that it can be much easier for me to start at P. We're going like right hand direction. So they said it's a right hand, meaning you use your right hand, it's going to go this way, then turn around, then go this way again. So after dividing your top view here, you project your lines up until this part. Yeah. After doing that, you will get these points, So wherever you see a cross, our first point is at P. Then our next cross, you move up, you go to the point. 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 You do the same thing. You see, it's like a pattern. It gives you a pattern. You move up, you go to that point. You move up, you go to that point. You move up, go to that point. Move up, go to that point. Do the same until that part. Okay. Now we have to draw our helix. So it's right hand, remember, meaning if it's right hand, this is the front part. We are going to see this part is going to the right. So this is the front part. We are going anti-clockwise, meaning it's going like this. Our helix is going like this. So we are going to start from P. We are going to see this part because it's in the front. And they said this is what did they say? This is non-transparent. Yeah, non-transparent, meaning it's not transparent. You cannot see behind it. It's a solid, so you cannot see that that line there, meaning you have to use hidden detail line. They said show hidden detail line and all necessary construction. So this is the all necessary construction where they're talking about. These are construction lines and numbering and calculations and all of that. So you use dotted lines for the hidden detail because this one is behind it now. So if this was in 3D, if this was in 3D, it was going to be something like this, going to be something like this. Then our line was going to be like this. Then it goes behind it. Then we're gonna set it up here. So our line was gonna be something like this, So same thing here. We do that, but now it's on a flat surface. Remember, it's 2D. So you do that. You continue to the lines. Then you do the same from this point. You connect your lines with your free hand. Then you are done. So coming to the questions. The first question is saying, what is the size of a pitch? So pitch, remember, pitch is from here to here. That's the pitch. It's from here to here. So what I did is I divided 33.3 by 6. Remember, this is from here to here is 33.6. So we have it's 33.33. So from here to the 33.33, we're divided by 6 parts. So we have 6 parts within this 33.3. So I divided by 6, right? Then I got 5.56 millimeters. So that's our pitch. Then they said the next question says, what is the developed length of a helical curve in 1 revolution, right? So in 1 revolution, meaning in 1 turn, from here you go around up until here. So it's 1 revolution. Yeah. So our height here, our height for 1 revolution is going to be sorry for that. It's going to be 66.66. It's going to be like this. Then our circumference, I found it. Here's the circumference. You remember the formula for the circumference. You say 2 pi r, meaning our our radius is 30, so I got 188.50 millimeters. Sorry for that, it's millimeters. Then it means now we have something like this. So this is how you get it. You have 66.66 here. Then now you're going to have 188.50 millimeters here. So you use your ruler to get this part here. It's going to be our helical curve length. Sorry, I've done like a mistake here. I will try to do it again. The method that I showed you, I forgot that I have to end here. Mine ends here. So they said for one full revolution. So I went an extra mile by going there. So the height here, don't mind this height, it's not 100, right? It's going to be that 66.6. Just do this method that I just showed you here. It's going to give you the correct answer. Then the helical angle, they said the last question, what is the size of the helical angle? So the helical angle is going to be I found it as 22.2. What I did is that I used my protractor. Okay, you use your protractor. First, you can use, as you can see, I don't know if you can see this construction line here, right? It's like a straight line that goes through this point, and fortunately it touches this one and this one too, so it's straightforward. So you just put your protractor like that at that point in the middle. At that point in the middle, it's going to be our protractor, right? So it goes this way. I found it to be 22.2. It's here, right? It's like it's a straight line through 0 through 22.2 degrees. So that's the final answer. It's supposed to be like this.